we're going to have a quick look at regression on Minitab, mostly about how you interpret the data, but also a little bit on what regression is, because if you know roughly what it is, it gives you confidence in your commentary. Amir's data. Thank you, Amir. And he has prepared this wonderful set of data with the variables as columns and the cases as rows. So this is one instance, as you can see, of Rolls-Royce. Their audit lag in days, presumably. Key audit matters, I'm not sure what M stands for. Word count, gross profit margin in 2017 for Rolls-Royce. So those are the data. And then who audited them? KPMG apparently in 2017, and that's a dummy variable, right? So it's 0 or 1, and in this case it identifies which auditor, and it's KPMG, and 1 for UK, 0 for foreign. So those are our variables. These are the number of cases. So Control C. We then, and I've prepared this a little bit beforehand, we then go into Minitab, and just to repeat what I've done, you do Control V, and then that pastes all the data. I don't know what that means. So the data, the names of the variables are given here. If it's not reading it as a number, it'll put T up here, and it's best to go back to Excel and make sure there's not NA at the top. Anyway, those are details. I'm just going to assume you can get a nice clean block of numbers here and put it in. You then want to run a regression, and the first thing you do is to work out what you want to do and why you want to do it. And in this particular case, we have a regression rather. On the left hand side we have audit lag, that's the length of time between the end of the accounting year and the date on the auditor's report. Then we have these KAMs as a factor, which is the number of issues found. We've got the word count, how long is the report. Then we've got the gross profit margin, net profit margin, and I've included one of the auditors, Ernst & Young. I've done that because I ran it with each auditor in turn, and none of them were significant except for Ernst & Young, sorry. And then we've got whether it's the UK or foreign. Right, so that is the basic equation that we're looking at. The rationale is, well, comes hopefully from the literature, that they've looked at these variables and there's an argument that it's going to be a longer gap if there are lots of issues raised. If it's a long report, it means that they've had to do a lot of work. If it's the gross margin, we thought, well, if it's negative, if it's a loss, then we might expect a longer delay as they go over it more carefully than if it's a profit. And then the net profit margin is a positive. Net profit margin, same sort of reasoning. Then, as I said, the Ernst & Young, whether they are part a cause of the lag, that they are a particularly slow set of auditors or quick, and then also whether it's in the UK or foreign. Do they take longer abroad or less long? So there's a kind of loose rationale that we get in the social sciences, I'm afraid, not as neatly tied up as, say, in the sciences. That's our regression equation. We now want to run the regression. The mechanics of that are quite straightforward. It's statistics regression. Just follow the word regression and fit regression model. So you go to there, and then it asks you which one you want, and you have to put these in. All right, so I'm sure you're quite capable of that. So to put the audit lag in, for example, you add and select, and then to put variables in here, I'll just re-enter this one. So to put that one in, that you just click it and make sure that you've clicked in this space, and then select, and it puts it in there. To get our basic regression, we just click on here, and it has a little think, and it comes up in this window. So to explain it, which is our purpose, hopefully you're reasonably familiar with Minitab. A quick way of doing it is to copy the picture. You can do that, and we can go back to our Excel spreadsheet, and we paste, right? So copy and then insert, in this case, insert pictures, right? And that's our picture, which I've already inserted. So we'd click on insert. We've got this regression, so now we need to interpret it. What is it doing? What's it all about? Well, I've got here a little example. You'll see the word in the literature as least squares. It can be called least squares analysis. And you see adjusted sum of squares. That's what SS means. So the capital S means squares, and R squared. So this word squares comes up quite a lot, and I think it's useful just to get a little explanation as to why that is, though the explanation would never form part of any dissertation output. However, I think it's useful to know. So what is this squares? Well, what the regression is doing, and this is a case where I've looked at the relationship between audit lag and gross profit margin. So if we look at this, the reason I did this was that I just thought the gross profit margin relationship to the audit lag. Let's go back down to the equation here. This relationship between gross profit margin and audit lag, just wanted to have a look at that relationship in isolation. And so we looked at it using the graph function, and with a scatter plot with a fitted line. So what is this line? We're going to treat this as the regression line through a set of points. And what it does is that it looks at the distance between a point and the line. And it measures that distance by taking the square of the distance. So it takes that distance squared. So it's really working out an area that is that size. And that's what it means. Then this is the unexplained square, and this is the explained square. So we also have this, which is the total square. Okay, so the line has explained that square. The error is this square, the unexplained bit, and the total square is that. And you can see quite clearly that this square plus that square does not add up to that square, it's less. So for that particular point, the point above, our two areas don't explain the total distance of the point from the axis. So that's our concept of squares. It's measuring the difference. Now that's a case where the total squares add up to less. That's not always the case. So well, let's just take a point below the line. Okay, so I've adjusted the squares. Well, that's not quite square, is it? I've adjusted the. That's more like it. I've adjusted the squares for a point below the line, and here you can see that this is the unexplained element, right? The deviation from the line, and this is the explained element, right? Perhaps I should use my explained one with this one. This is the explained element. Let's just so our light blue area is explained, that is the unexplained, and our total sum of squares is going to be something like that. And there you can see that our explained square plus our unexplained square is now greater than our actual, our total sum of squares, the actual sum of squares. So the process does this at every point. And when we look at our output, we see here the sum of squares here. And this is the total of the sum of squares that are explained by the line, that 4390. And going back to our line, it is the amount is this light blue square, this one. I just move it up and down like that. That's our explained sum of squares. And so that's the total of that. And this is the total of the unexplained, the error as they call them here. And the unexplained element is this little square. The squared difference between the point and the line. That is the unexplained element. And that is what regression is doing. The total sum of squares is given here as 13585.2, is this error, the squares of the errors that we've just been looking at, and the total of the squares of the regression. And our R squared is simply the ratio of the regression, the explained sum of squares, divided by the total sum of squares. And that is just a way of fitting a line that minimizes the distance between our observed points and our line. And that is what we are aiming to do by minimizing that distance. Just take all our little squares away. Minimizing that distance, we supposedly come across a relationship. But obviously that relationship may not exist. Now, in this example, you can see that the actual relationship between the two is very low to non-existent. However, when we look at the regression model, we can see that if we look at the gross profit margin, we see that the sum of squares, that particular variable explains is significant. So why is it significant? Well, if we look at this p-value, which is incidentally the same as the p-values down here, this is saying that well, actually, it's probably better to look at this p. No, I'll delay that explanation till we have a look at this actual equation first. Okay, so we have this regression equation here, down here, and this is the slope of these lines that at best predicts audit lag. We're saying therefore that it's 559.74 minus 0.332 times the KAMs plus this very small number times the word count, and so on. Now, the thing about this equation is that you don't want to take too much notice of these coefficients because they depend on the scale of the particular variable, what's called the explanatory variable. So word count is on a particularly big scale because there was a wide variation. So that's why that's small. It's just a matter of the scale. What you are interested in is whether the word count is significant in explaining the audit lag, or whether it's just a measure that they've put in, but it could equally well be zero. If that what's called the coefficient is 0, then it means that whatever the word count is not going to affect your audit lag. So that's the critical thing. The fact that it's a small number doesn't mean to say that it's close to 0, right? It is what we call significantly different from 0. And that means that if we repeatedly tested this, then we would still have this small number. It wouldn't go to 0. Whereas some of these other numbers, say the KAMs, 0.332, that's a much bigger coefficient. That could equally be 0. The fact that it's a bigger slope isn't significant because the error or standard deviation around that value is very wide. So it's like, well, it's made a guess at 0.332, but it could be 0. Whereas here, it could be it's come to 0.000, and it's 1, 2, 3, 0.000965, and it couldn't really be much either way around that. So it's this idea of spread that's important, not the actual number itself. And if we look at the coefficients here, which are the same as these coefficients here, you can see that. The question we want to ask is this really 0, right? Because if it's 0, then it's not significant. And this is the probability that this coefficient is 0. So where we see this probability as being high, as in the KAMs, it means there's a 38% chance that this is 0. So that minus 0.332 doesn't really matter, right? It could have been 0. Whereas with the word count, we see that there's a 5.6% chance that this is 0. So although the number, as we were saying, is small, we usually take 5% as the cutoff, but in the social sciences you can creep a little bit above that. It's 5.6%. So it is just about significantly different from 0. This is more clearly significantly different from 0. So all these variables would appear to be significant, in explaining the length of the audit lag. They're all significantly different from 0. But even with these, we mustn't take the actual value too seriously. All we can say is that it is significantly different from 0 with this selection. Now, the worrying thing is that if we select, we haven't selected all the variables. If we did select the other variables, these values are going to change a bit. So whatever you do, don't start sort of giving examples of KAMs and putting it into this formula and then coming out with an audit lag number. It isn't that precise, I'm sorry to say. What you should be doing is having a look at the p-values to see whether they are below, at or below 0.05. If they are, it means this is not 0 and therefore has a significant effect on audit lag. Right, so we now want to think about what this equation means. For the KAM, we dismiss it, right, because it isn't significant. So we can't, well, we don't dismiss it, we say it isn't relevant. Now, you may have good reasons as to why you think it is relevant. And so a zero significance or not significant can be a very important write-up. And that's important. That's why it's important when formulating your question to do it very carefully, so that if it's not significant, that's interesting. If it's significant, that's also interesting. So it's got to be interesting in both directions. So the KAMs, good reasons to expect why that might produce a lag, but apparently it's not significant. The word count is significant, not too surprising. If they produce a long report, it's taken them longer to do it. Obvious conclusions are perfectly satisfactory. The gross profit margin. So this is saying that the higher the gross profit margin, the lower the audit lag. And that is kind of what you'd expect. So if the company has made a big profit, the auditors, well, I say expect, the auditors apparently don't take as long. Right? They're not as worried, if you like. But if it's made a loss, right? It's a low gross profit margin, then the audit lag is higher. So you've got to get used to these inverse relationships. Higher the gross margin, it's a negative one, so it has a negative effect on the audit lag. So the higher the margin, the shorter the audit lag. And the puzzling one is the net profit margin, because this is saying that the higher the net profit margin, then the longer the audit lag. So that's a real little puzzle that we've got there. Then, as I was saying earlier, I put in all the auditors one by one to see if they played a significant part, and none of them did except for Ernst & Young, and it would appear that if Ernst & Young are in an audit, they take rather longer. Now, that might just be because your sample is small and the number of Ernst & Youngs was small and they happen to be big, long audits. So that's one of the problems of having a small sample, is that you can get results that are difficult to interpret, and it may just be a bit of an accident. And unfortunately, the regression won't necessarily pick that up. So you must be very careful, especially if your sample is quite small. This has 89, so that's really quite a large total to have, sorry, 90. That is quite a large total, but even then, the number of Ernst & Young audits might have been quite small in the sample. And this is where you would go to your diagnostics. So let's just go quickly back to Minitab. You should always, with your any analysis, you should always put in your descriptives. So like that. So Ernst & Young, oh, I was hoping it would tell me how many Ernst & Young observations there were, the ones. Oh, I suppose I could work it out from that. I can't. My head hurts. Anyway, it's the total of this column. I don't think there are too many there. 1, 2, 3, 4, 5, 6. It looks as if there are only 6, so that's a really small number. Your result here could just be the result of that, and it's important in a write-up to be, prepared to say that maybe this result, although it looks significant, isn't really significant. You're not getting any marks for finding a particular solution. You're getting marks for your methodology. And so finding a significant result and then questioning it and perhaps, finding it's either fine or not fine is a very good thing to do. You don't want to give the impression that I am somebody who worships numbers, and if the p is below 0.05, I bow down and say it's an explanatory variable that's very significant. Now, if you say that sort of thing, clearly it doesn't impress anybody. Taking this skeptical attitude towards everything is therefore good. We have our analysis here. We had an explanation as to why we were using these variables. That should come from the literature. We've looked at the significance of these variables, and the only other thing we can do is to look at the relationships, particular relationships that we're interested in. You've got to be careful though, because the relationship between the gross profit margin and the audit lag, that relationship is a relationship after controlling for these other variables. And that is the general problem in regression. And there might be some hidden variables, the model is never fully specified. The actual direct relationship between the two might not be very good, and in fact that's what we see here. This is not a particularly good relationship. The R squared, as you can see, is very small, and that's obviously true. Now, the point about the regression is that that was just 2 dimensions. One dimension was audit lag and the other gross margin. This is a multi-dimensional. Each one of these is a dimension. And when we control, as I said, for these other dimensions, in other words, include them then our gross profit margin is making a significant contribution. So you can't necessarily just pull out a particular variable and look at its relationship independently of these other variables. Nevertheless, if it is a strong relationship, you'd kind of expect it to be related. But in this case, it appears to be quite dependent on the other variables and their relationship. And that's something you always have to be aware of. If you're looking at the relationship between A and B, you must always be aware that there may be numerically a strong relationship, a strong correlation between A and B, but that isn't the true correlation, that there's an intervening variable, C, And really what you're looking at is a strong correlation between A and C and B and C, and that there's no direct relationship between A and B. So you must always be careful in talking about relationships between individual explanatory variables, that there may be another missing variable not included and maybe not measurable. So, in pricing, expectations are very difficult to measure, and in many ways have the role of C in this relationship. Right, so the only other thing here is we've got our unusual observations here are the large residuals. So these are points that lie well off the line. And it may be that you're looking at a relationship and there are one or two that are that have very high deviation as measured by the residual. So that's this figure here. So there may be very, very high variation, and it may be that you want to take out that individual observation. Again, that's a good reason to have a big sample. But really, you don't want to do that too much, because it looks as if you're trying to massage the figures, as if you're trying to find significant values, when you should have set up your analysis so that you shouldn't be afraid of getting values here that are not significant. In other words, these are 0 and or could have been 0, and the R squared is very low. So you need to work very carefully at your research question because of that issue. Well, that's been a very short introduction to regression. I think I'll take a pause and just do a quick summary. Okay, I've now put together a little list of things for you to think about, a kind of pathway in analyzing, just to reiterate that here's the equation. These values are called the coefficients listed there. These are called the explanatory variables. This is called the explained variable. Follow these. I won't read over them, and you should be able to produce a reasonable standard analysis of a regression. Okay, thank you.